All right, so your homework is page 176, numbers 1 through 4, 11 through 15, 19, and 20. They all have to do with Rolle's theorem. So that's today's section, section 3.2. So section 3.2, Rolle's theorem. Now, it's actually two things that happen in this section. It's Rolle's theorem and the mean value theorem, which is a super important theorem. Rolle's theorem is important, but it's not one that you have to have memorized. The mean value theorem is one you have to have memorized, so we'll talk about that one tomorrow. But Rolle's theorem, basically what it does is that it tells us that if we could prove that 2 points within an interval are at the same height. So let me just kind of give you a quick insight into this. So if I can show you that there are 2 points, okay, let's call it A and B, that have the same value. Okay, so in other words, f of A and f of B are the same height, right? So I guess you could call it like the height of 2 or something. But if I can show you that there's a function, all right, that's nice and continuous, differentiable, a nice clean function that has the same height between 2 intervals, then Rolle says that he can guarantee that there's at least one extrema within those intervals. In other words, maybe your graph looks like this. Okay, or maybe your graph does something like this. Or maybe the graph just goes straight across. Okay, I'll kind of zoom in real quick just so we can talk about that. But we have 3 different situations, right? Notice you can tell that f of A and f of B are equal, right? They're both at the same height. So if both f of A and f of B have the same value, if they're equal to each other, let's look at the blue line, okay? On the blue line, you could say that there might be a relative maximum right there, just one of them. On the green line, you might say that there's a relative maximum here, but then also 2 relative minimums. In our case, maybe one of them is going to be an absolute minimum, but still, there's extrema there. There's 3 of them, right, for the green line. There's 1 for the blue line. The purple line, there's an infinite number, right? Even though it's just like one value. But the whole line itself is a max and a min because it doesn't go any higher or lower than itself. So the whole line would be its max and min, right? So what Rolle's theorem basically says is if you can show me for a function that's continuous and differentiable. Okay, differentiable means you could take derivatives throughout the whole function. Okay, there's no cusps, there's nothing tricky about it. It's a nice continuous function. If you can show me that there's 2 values that have the same height, in other words, f of A equal to f of B, then he says, I guarantee you that there will be at least one extrema. Okay, so let me write down that definition. Okay, so Rolle's theorem. So Rolle's theorem states, if f is a continuous function on the closed interval a to b and differentiable on the open interval a to b. Now, if you guys remember, the reason why we have to say differentiable on the open is because you can't take derivatives at the endpoint. So you have to exclude the endpoints, okay? Derivatives cannot occur at endpoints. That's why you can't have relative maxima and minima at the endpoints, right? You can have absolutes, but not relatives, okay? So if f is a continuous function on the closed interval a to b, and differentiable on the open interval from a to b, and if f of a is equal to f of b. Then there exists at least one number c within a to b so c is somewhere in between a and b. Okay, so there exists some number c, at least one, within a to b, such that f prime of c is equal to 0. Remember, f prime of c equal to 0 means that you're trying to find relative extrema. Okay, so it's basically saying, hey, make sure that the function is continuous, make sure that you can take derivatives anywhere. Normally, being able to take a derivative anywhere is just fine, unless your function's kind of tricky, like an absolute value function. Because you can take a derivative of absolute value function everywhere, except for where? So where? It has a certain name, starts with a C. A cusp, right? At the cusp. Anywhere else, it's fine, okay? So anywhere else is just fine, but at the cusp, not good, okay? Tangent of x, it's not continuous. It's also not differentiable at specific places because it has a bunch of asymptotes, right? So you got to think about the function itself. Does it fit the bill? Does it have continuity? Does it have differentiability? Okay, and after you check those two things first, okay, so if I can, I'll kind of highlight this. Continuity, differentiability, right? If those things are true, then you check f of b equal to f of a, or f of a equal to f of b. Okay, is it true that f of a is equal to f of b? All right, and if that is true, then you know you can find some number when you take the derivative, that if you set the derivative equal to 0, that you're going to be able to solve for it, okay? And that'll be a relative extrema, either a max or a min, something like that, okay? So let me show you guys how this works, okay? Let me give you an example. So this is going to be example number 1. Says find the two x-intercepts of f of x equal to x squared minus 3x plus 1. Show that f prime of x equals to 0 at some point between the two x-intercepts. So they want us to find the two x-intercepts of that function. Okay, that's not calculus, that's just algebra. And then it says, and then show that f prime of x equals to 0 at some point between the two x-intercepts. Well, that whole second part is, they're telling you use Rolle's theorem, because when they say to show that at some point f prime of x equals to 0 between those two x-intercepts, don't x-intercepts always have the same height? Right? Aren't they on the x-axis? So their height would be equal, right? So whenever I find my two x-intercepts, that means that f of a, whatever it happens to be, would be equal to f of b. So they're saying, show that that's true. In other words, prove to us that, yeah, they do have the same height. Okay, I kind of just did it verbally, but we'll do the work for it right now. But the first thing at hand is we need to show or find the x-intercept. So let's do that. So we have f of x equal to x squared minus 3x plus 1. Now, if I want to find the x-intercepts, I'm going to take the function and I'm going to set it equal to 0. That's basically saying, when is its height equal to 0? The problem is I can't factor this, at least not normally. So I'm going to have to complete the square. Right? So x squared minus 3x is equal to negative 1. Okay, and then we're going to have to add on both sides, right? You got to take b over 2 quantity squared. So let me write that out here. We got x squared minus 3x plus something equals negative 1 plus something. Now that something is your b term. This is your b term right there, okay, negative 3. You're going to get it and divide it by 2 and then square it. So that's a 9/4. And now we factor. So this will come out to x minus 3 over 2 quantity squared equal to 5 over 4. Okay, now to solve for x, I'm going to have to take a square root of both sides and then add a 3/2. Okay, so we're going to take a square root of both sides. We get x minus 3/2 equals to plus or minus the square root of 5 over 2. Okay, so x minus 3/2 equals plus or minus square root of 5 over 2. Now let's just move the 3/2 over and we have our x-intercepts. X equals to 3/2 plus or minus radical 5 over 2. So they want us to find the two x-intercepts. Here they are. Okay, I'm going to write them down. 3/2 minus radical 5 over 2 and 3/2 plus radical 5 over 2. Now, of course, you can just write it as plus or minus, but I wanted to write it as two actual values just for the purposes of Rolle's theorem. Okay, so I got two of them. Now, right now, I'll come back to this part, but the first part of the instruction said, find the two x-intercepts. There you go. We found both of them. Now, the next one said, show that there is a value where its derivative is equal to 0. Okay, show that there's a value where the derivative equals to 0 between those intercepts. So they're saying apply Rolle's theorem. Now, in order for me to apply Rolle's theorem, I have to go in order. I have to look at my original function. Let me put this right here for part B. F of x equal to x cubed minus 3x plus 1. And I got to ask myself, is this function continuous between that interval? I know it's a weird looking interval, but is it continuous? Well, this function is a polynomial, correct? And I always say polynomials are always continuous, right? So all right, great. So we have that being true. Okay? So polynomials are always continuous. I don't know what it's doing right now. I'm not touching it, but it's doing something. But anyway, so we have that. Is it differentiable? Well, since it's just a polynomial, it shouldn't have any cusps or anything weird going on with it. So I would say it's differentiable. So the next step is, do I have an interval where f of a equals f of b? In other words, is it true that f of 3/2 minus radical 5 over 2 is equal to f of 3/2 plus radical 5 over 2? Is this true? Now remember, what are those points indications of? What did I find in part A? My x-intercepts. So should they have the same height? Yes. So according to Rolle's theorem, I have shown that, or not even shown, but I know that the function is continuous. I know that the function is differentiable. I know that f of a equals to f of b. So if all that is true, then what does the theorem say? Well, let's look. The theorem says if, okay, this part, if it's continuous and differentiable, and if this is true, then there exists at least one number c within a to b such that f prime of c equals 0. Okay? So, in other words, now that I've shown all that stuff, then exactly what they want me to prove, I can now just state it. I can just say, since f of x is continuous and differentiable, and since f of 3/2 minus radical 5 over 2 is equal to f of 3/2 plus radical 5 over 2, then, so notice I'm just stating what I'm supposed to prove to them, okay? If all this stuff is true, okay, but I'm saying since, I'm not saying if, I'm saying since it is, then there exists an x value within, this is going to look kind of weird, but here we go. Here's my interval. Within that interval, such that f prime of x equal to 0. So I'm done with this problem. Notice I didn't actually have to like solve for anything. Now I am going to do that just to prove a point, but this problem just said show us that this is true. Well, there it is. Okay, I showed you that there was continuity and differentiability. I showed you that f of a equals f of b. So if I can show you those three things, then you guaranteed me that there will be one of these things. How many of them? At least one, right? So I could put right here, at least one x value. At least one. There could be 30, I don't know. But there's going to be at least one. Roll guarantees that. Okay, the theorem guarantees that there's at least one. Okay, now usually they're not going to ask you to do this on any type of test. Usually they're going to say, well, can you find it for me? So here's the part that that's extra. Okay, we're actually done with this problem. But I'm going to do a little bit extra because a lot of the stuff in your homework is going to say, okay, great, well, what is it? Right? So this is what you do. You're going to get your f of x function, which is x cubed minus 3x plus 1. And you're going to take your derivative of it. So 3x squared minus 3. Wait a minute. Sorry. I just realized I wrote the... Wait, did I write this? Yeah, I did write it. Okay. Okay. So, it should be an x squared, shouldn't it? Yeah. Where did I write it wrong? You wrote it. Oh, I wrote it wrong in part B. Okay. I'm like, wait a minute, this doesn't look right. Part B should be a square, because the original was a square. Yeah, it was a square. Sorry about that. I'm like, that doesn't look right. So the derivative of x squared would be 2x, right? So 2x minus 3. And then I'm supposed to set it equal to 0. So 2x minus 3 equals 0. That means x is equal to 3/2. So there is that x. There's only one of them. If there is more than one, then we would have solved for more than one. Okay? but there's only one of them. Now, if I want to prove it to you that this is actually a max or a min, I can do that. I can say f prime of x. Let's make a sine graph for this thing. Here's 3 halves. Over here is 3 halves plus radical 5 over 2. Over here is 3 halves minus radical 5 over 2. Now, do you have to do this? No, you don't. But if for some reason you need to show them that you know what it is. Because right now you don't know if that's a maximum or a minimum, right? You just know that it is an extrema. But if they say, well, what kind of extrema? Is this a high point, a low point? What's going on? You probably should be able to tell because the equation is an x squared minus 3x plus 1. You know that's a parabola that opens up, so you should be able to tell that that's a low point. But if you did not, then what you do is you pick points. So f prime of, we can pick 1 and we can do f prime of 2. Those are numbers between here. Okay, those numbers are right here and right here. They're right in between, a 1 and a 2. So if I plug in a 1 into my derivative, I get 2 times 1 minus 3. That's negative 1, so that's a minus. And then if I plug in a 2, I get 2 times 2 minus 3. That's a positive 1. That means this graph is going down, then up. So if they really wanted me to be specific, what kind of extrema do I have? Well, I'd have a relative minimum. And actually, since this is a parabola, that would be an absolute minimum. Okay? Now, you don't have to do all this work for part B. Part B just said, show us that this is true, so I did. That's the stuff in red. Everything in red, right now I'll go back down, but everything in red is the show me part. Show me you understand. Okay? Show me you know how to use this theorem. After that, it's the, okay, now can you find the value and can you prove to me what kind of extrema it is? Right? The stuff in blue is me going through the process of finding out how many of them and what are they. The stuff in green is me saying, okay, I found them. Now, is it a high point or is it a low point? Okay? So, all that blue and green stuff, that's extra stuff, but that's stuff you have to know how to do because your homework is going to ask you to do this. Maybe not the show me part, but at least the find it and prove it. Okay, show me that it is a high or low point, something like that. So I'm going to show you one more example on this, and then we'll stop, okay? So this is going to be example number 2. Let f of x equal to x to the 6 minus x squared. Find all the values of c in the interval -2 to 2 such that f prime of c is equal to 0. So they gave us a function. Okay, they said find all the values of c that make f prime of c equal to 0 within the interval -2 to 2. Now, again, you got to go through the process of Rolle's theorem. Is x squared minus, x to the 6 minus x squared continuous? Well, it's a polynomial, so it should be. Is it differentiable? Yes, polynomials are differentiable everywhere, okay? Is it true that f of -2 is equal to f of 2? Well, I don't know that yet, but let's find out. F of -2 is going to be -2 to the 6th minus -2 squared. That's 64 minus 4, so that's 60. F of 2 is 2 to the 6th minus 2 squared. That's 64 minus 4. That's also 60. So f of negative 2 is equal to f of 2. So Rolle's theorem is holding up so far. We have continuity, we have differentiability, and we have f of a equal to f of b. So then according to Rolle's theorem, it says, okay, well, if that's true, then there does exist at least one of these things. Okay? There does exist at least one extrema, where if you take the derivative and solve for 0, you can find it. So they're saying, find all the values. So let's do that. So f prime of x is 6x to the 5th minus 2x. Okay, now if I set that equal to 0, I'm actually going to take out a 2x here. So that'd be 3x to the 4th minus 1 equals 0. I can set up equations here, two different ones. 2x equal to 0. And 3x to the 4th minus 1 equals 0. So the first one's easy to solve, right? X equals 0. The next one, you just add 1 and divide by 3. And take your 4th root. Now, since the 4th root is an even root, then you have to include the plus or minus. If it's not an even root, then you don't have to. So how many extrema do I have? 3, right? 0, radical, 4th root of 1/3, and negative 4th root of 1/3. And that's it. Those are my 3. So I would just write them out right here. X equals negative 4th root of 1/3, 0, and the 4th root of 1/3. Now, if they ask you to prove it, then you're going to have to do a sign graph. Okay? So you would have to do a sign graph and show like, okay, it is true that the following is going to happen. Okay, and you got to show that it's going up and down and stuff like that. You can easily just draw this in Desmos, look for those points and see that it is changing direction there. So you do have increasing, decreasing, that type of stuff. So, all right, so that's where we're going to end for today. Tomorrow we will do mean value theorem.